Okay. How's everybody? Everybody gets pizza? Good stuff? All right. Good now? Good. Thank you for everybody bringing stuff. Appreciate it. Wanted to make sure you knew last week, the great presenters last week, your podcast is up there already. In fact, it was up there right after the session. And also links to whether it be a download or a direct link to Prezi, Casey has Prezi. And so, same this week, we'll do the same for you guys. A little different as far as presentation order goes. Colin isn't here tonight, but he submitted a screencast we're going to watch first. And then let's see what order here we'll go in tonight. Let's see, we'll do server hardware, Joe first. Russ, all right, second. And Mike third. How's that? Sound good? There will be a mic, everybody. You guys are wearing advance here if you need. Whatever you do on my Mac, you may do. So, as far as grades go for the semester, they'll be finished by Monday, and I'll post them by next Wednesday on online services. And so it should be like available online service like Thursday or Friday. It takes like 24 hours to post. And so you guys have been a great class. Hope you learned some things in networking and networking essentials and a lot to networking. But it's one of the fields that's continually growing, continually morphing. If you like change and you like to do a lot of different things, wear different hats, you more than likely would love to go into some form of networking field because there's so many different avenues to go in, not just in the hardware side, but you can also go into configuration side, you can go into the security side, like in the 130 class covers, and you can go into the programming side of networking and management, risk assessment, a whole bunch of different fields to go into. In fact, I just did a search this afternoon, and I think let me see if I can find that stat. It was, see if I can pull it up here real quick. Slides here is the latest job search for networking folks here in Illinois. Yeah, this was last week's stats. Over 1,000. It was just 1,000 plus is what it said on Monster. 1,000 plus networking type of jobs available in Illinois alone. Within a 100-mile radius of Rockford was around 700. So within Rockford and 100 miles from Rockford, over 700 networking jobs, from networking techs to admins to you name it, Cisco folks, Microsoft folks. So that tells me that there's a number one, need more trained folks in networking, those interested in networking, and believe me, there are places that are just can't find people. They just literally can't find people, and so that's sad to say. Why a lot of times businesses ship a lot of their stuff overseas because they just can't find people to fill the jobs, and people complain to keep a job in America, which I'm all for it. But a lot of it is too, they are hard pressed to find folks interested in those type of fields. And so I don't know if it's just because I don't think it's people aren't interested. I think people just aren't aware. Just like that job stat, 1,000 jobs. Did you know there was 1,000 networking jobs 100 miles from Rockford, within a 100-mile radius?
Challenging.
It is a challenging field, yeah. It is. It's challenging field, but it's if you like a challenge and you like to learn, you're constantly learning. It's not one of those fields where you go in and what you learn now is the same 5 years from now, or a year from now, or even 6 months from now. It can change. And so some people, I think that's fearful for some, maybe, is reluctancy of the change. It's constantly changing. So but if you have that type of personality, then you'd love it. It's just constantly moving. It's never the same. And there's always new technologies on the horizon. Right now, networking, what's used is cloud computing and anything about cloud storage is huge right now in networking. And so, I encourage you to, even with this class under your belt, you can, like do a network tech job or something to start getting your feet wet in networking. Installing software, setting up computers, printers, troubleshooting, stuff like that. And that's where I recommend students to start out at. And around Rockford, believe it or not, there's jobs that you can get in that field doing just that, tech jobs. Now, pay-wise, anywhere from 13 to 18 bucks an hour, roughly, in this area, but still not bad pay for an intro type of position. So that's my little spill on networking essentials. I know I have a few of you next semester. And by the way, numbers are all great for next semester now. They're all going on the courses for fall. I think we've got 13 or 14 in my 130 class, and in the 110 class, I've got 12 or 13. And so pretty happy with that. So pretty pleased with that. So I don't know if you guys helped in that and shared a little bit, but if you did, I appreciate it. And then last night, I don't know if you guys saw the post, but I was out of the blue. I was emailed a couple weeks ago about I was nominated for a social media award here on campus from marketing department. And so I'll pull up, my daughter went with me because my wife's out of town in Springfield, Missouri with our son. By the way, this person keeps popping up. That's Natalie. She's one of our alumni, actually. She's working for Dell, and I guess she's doing some piloting, but I doubt it. It's probably some spoof about something. She didn't answer. But anyway, she's a great programming networking student. She's from Soviet Ukraine. So let's see here if I can pull up a picture from last night. Oh, there it is. There's the award anyway, right there. Pretty awesome. And and then here's all of us that won. This is, I believe, a student in one of the student clubs. These are all student club winners, basically. This was a follower award. Then this was like selfie, best selfie, I think. He won best selfie. And then I think hers was something creative, some type of creative post that she did. So anyway, we had a lot of fun. They had like a little photo booth you could go into and take your photo. And so that was a lot of fun. My daughter and I did that. So they had a dance afterwards. I didn't stay for that, but kind of snuck out after the award ceremony. But anyway, it was a lot of fun, and it was one of the benefits, I guess, of social media for me is, I know Benita's helped a little bit, you've helped a little bit, Roma's helped a little bit in social media as far as on the web and stuff. But one of the latest articles in the Harvard Business Review is employers are now looking at social media very seriously when it comes to hiring people. And so you can use it in a very positive way, but also a very negative way too. And so I encourage students to definitely have, like LinkedIn is one of the main places employers go now for when they're looking for employees, future employees. And so you can even post your resume on there now, and a lot of cool stuff you can do. And LinkedIn is becoming the #1 job source for college students to be able to find jobs. And so, but spring 2017, a year from now, or actually next January, I'm offering a social media management course to see how it goes, just a pilot kind of thing. And so I announced it last night to the group that was there. And so if you're interested, it's already in the books. I've already got the outline and starting to gather material. It'll basically be able to be going over how to manage social media for businesses and medium, large size businesses for both Facebook, Twitter, and LinkedIn, and be able to manage that and the tools that you use in it, the techniques. Trying to work out a way to where we can go to a social media conference next semester, or the spring semester, to where you kind of really get to see all the cool things people are doing in social media. So if you're interested, it's going to be a 3-credit course, and it's going to be online, and that's another positive too. And so students love online classes. I love online classes. So hopefully that'll help with interest. So if you're interested, or if you have questions, let me know. Love to have all of you guys in there. It'd be great. Okay, so let's go and start with Colin's presentation. And he again did a video, and need to make mention, if you go to week 16, there should be a link to the survey. If there's not, we might use the one at 15. Tell me if there is. Is there? Okay. So if you could use that, that would be great. Is it in the, I'm guessing it's probably in the task, but it's not. 16 task, I'm guessing, right? So if you could click on that link now for Colin, and then the other ones as they come up. So, all right. There we go. And as always, when those are presenting, make sure and pay attention to the presenter. Act interested is always nice. If you do have questions, you can, if they're real, all questions are important, but if there's something that, you think, well, maybe they might need to do some research on this, or it might be a little bit deeper question, you might put it in the survey for folks. But if it's, if you have a question, definitely ask a question at the end. With Colin, you're going to have to all put in the survey because he's not here. So, all right. So let's go ahead and start with Colin's presentation.
Hello, my name is Colin Rockmeyer. My research topic is VPN, which stands for Virtual Private Networks, which is a communication network that uses a combination of technologies to secure a connection to send data to the internet. Okay. When you use the VPN is when you're looking to connect with private networks or internet. If you're looking to access restricted content on websites that restrict different countries and private, anonymous browsing, avoiding surveillance, or ensuring Wi-Fi privacy. How does it work? It uses tunneling, which is opening a secured connection between devices in which encrypted data can pass through. I have an example of that. Basically, you got your PC that you're using to connect to a VPN client, which is tunneling through the internet, connecting to the VPN server, which then connects to the remote host. Okay, so how it works is the client sends packets, and the packets get encapsulated or wrapped in new packets, new header, and the header provides routing information to traverse the internet. Logical path that packets travel, that's the tunnel. When the packets reach the tunnel endpoint, they are encapsulated and then forwarded to the final destination. Both tunnel endpoints need to support the same tunneling protocol. tunneling protocols are operated either the OSI layer 2 data link layer or layer 3 network layer. Each security protocol supports two modes of operation: tunnel mode and transport mode. The tunnel mode encrypts the header of the data of each packet, while transport mode only encrypts the data itself. Okay, so what I'd like to talk about is the tunneling protocols. We've got the IPsec, that's Internet Protocol Security, that negotiates the required security protocols and secret keys that it uses. There's two main protocols that IPsec uses, which is authentication header and ESP encapsulation and security protocol. Authentication header provides the source authentication, and the ESP provides the encryption. Okay. There's also layer 2 tunnel protocol and point-to-point tunneling protocol, SSL, which is secure web browser. And also OpenVPN, which is open source software application, and that's also a very good option to use. Okay, also there's the IPKE protocol, Internet Key Exchange. That's a default protocol for IPsec to negotiate protocols and keys used between two parties. Pretty much to automate the usage of encryption on both ends of the tunnel. Okay, so some questions you might have, free versus paid. I would definitely recommend the paid ones. They are more secure. Free ones are unreliable, overused, and also very insecure. The paid ones give you more options and more secure connections to use. Some good ones to go with are private internet access. That's the one I'm using right now. Also Viper, VPN, PureVPN, and the free ones you can look into as well. OpenVPN is an open source VPN, which is another good option if you're technically inclined to set up your own VPN server. You can go with that option. Okay, so what I'd like to show you now here is how I connect with the VPN program and use the private internet access. So what I'm going to do, first thing I'm just going to check my IP address here. Here we go. And then I will connect me to Netherlands. Okay. And now that I'm connected to Netherlands, you can see my IP address is changing right now. So now it is this one here. What I'm going to try to do is go to the website, and I'm going to Hulu. I'm just going to see if it'll let me view it. Alright, to navigate here. sorry, currently our video library can only be watched from the United States. So if I was traveling in the Netherlands and I was trying to watch Hulu, what I would do is use a VPN client like I'm using, and I would connect to a US server somewhere in Texas or Florida or wherever. And if I was doing that, then I could be watching Hulu if I was in the Netherlands. Since I'm doing it the other way around, it won't let me connect from the Netherlands. So that's just a good example of how a VPN can change your IP address and allow you to get to different websites that would otherwise restrict your IP based on your country. Okay. Two more things that you should be aware of on VPN security. You want to make sure your machine is up to date with antivirus software and firewall. Make sure that's configured and working, and make sure your VPN connections are being authenticated and not allowing any outside connections aren't being authenticated on the network. So that basically concludes my presentation with basically way too much information or technical jargon that goes into explaining VPNs, and it's just too much to get into. So to be real concise, I just covered basic terms. But what I've also done is drawing a picture to kind of illustrate how the VPN works. So you have the company here in London that's private internet, and it's using a VPN server in which a few VPN clients in the US are connecting to it. And the VPN is creating this secure tunnel using a various combination of technology, namely IPsec, L2TP. The other ones are PPTP and SSL. So the clients are sending the packets, which get encapsulated in a larger package with new headers, and the original data in the packets get encrypted and broken up and then encapsulated and wrapped in new headers, which get authenticated and then sent through the tunnel. Once they get received at the VPN server, they are decrypted.
You guys can't even see that, can you?
Final destination.
I can see it great on my computer. I'm sitting around, man, it's pretty interesting. No, it looks white.
Yeah.
So you get to see it after the class, but it actually is a pretty awesome drawing. All right, I'm not going into
If there are
that.
any questions, just feel free to send me an email, and have a good night.
Yeah, the drawing was pretty awesome, by the way. It's a pencil drawing, but it's pretty awesome. That screen seems like really bright. It seems like almost white out. We're going to get some more pizza. Post session. Oh, do watch his video, because at the very end, the drawing is pretty intricate. It looks pretty good. It's hand drawn, so. But I look over like, wow, that's like totally white. All right, let's see if I can make this screen less bright or something. Let's do it all the way. Whoa. guys get your plate refilled. All right, so let's see here. Let's switch gears here. Go and refresh your survey. And let me just refresh who's going here. We got, let's see, Joe first, right? Then we've got Russ second, then third, Michael. All right, and I will get it started and let you put this on if you let you take my place. All right, so it's all yours.
Thank you.
All right, let's get your attention. The native links and healthy.
All right, so tonight I'm going to talk a little bit about server hardware, and some of the different features of server hardware I'm going to talk about is the form factors, the motherboards, processors, hard drives, RAM, operating system, and redundant and hot swap components. Form factors. There's three main types of form factors, servers. Towers is one of them, which is similar to your desktop computer, similar to the ones we have here, same size, shape. It's one of the more inexpensive types of server form factor, and these are suitable, and you'll find them in small businesses and home offices running servers. Second type, which is a fairly popular type, is the rack mount server. It's based on a standardized form factor, 19 inches wide, 1.75 inches high. Common sizes are 1U, 2U, and 4U, which is how many 1.75 inch units high it is. And each rack that they mount in is typically 42 units high. You'll typically not see a rack 42 units high full of servers all the way. Typically you'll see 40 or less servers mounted in a rack. They need airspace, typically cabling space. But you will see a fair amount of servers in a rack. Smallest form factor that you see in form factors is blade, which is vertically mounted server blade that's mounted into an enclosure, which then mounts into a normal standard server rack. In the server blade enclosure, you'll have several to many vertically mounted server blades mounted into that, and they use a standardized power connection and connection for data that plugs into the enclosure, which then mounts into the rack. Within the server, you'll have a motherboard. The motherboards for servers are fairly different than the motherboards you find on a normal desktop PC. As you can see by this picture here, this is space for 4 separate processors. You will see single processor motherboards, but in a lot of cases in servers you'll see multiple processor motherboards, which will have 2, 4, or even up to 8 different sockets. You'll also note there is a large amount of RAM slots on a server motherboard. Typically servers have quite a bit more RAM than a normal desktop or laptop computer. With the processors that mount onto a server motherboard, there's 2 main brands that compete in that space. Intel, of course, everybody knows about their Xeon series, and then AMD and their Opteron series. A little comparison between the two. The Xeons can run from 4 to 22 cores on a single chip. Each of those cores can also be multi-threaded, so you can have up to 44 threads of execution, and they're designed to work in either 2, 4, or 8 socket motherboards, and each socket on the motherboard can support up to 1.5 terabytes of RAM, which for most people that's what they have for their hard drive space, but servers you'll see that as just their RAM allocation. So if you had an 8 socket server motherboard, you could have up to 12 terabytes of RAM addressable. The Opterons are similar, the 4 to 16 cores. There again they can support multiple threads per core. They can be designed up to 4 sockets on the motherboard, and they can have support up to, there again, up to 1 terabyte of RAM, typically. So you'll see this. You see that the processors and the RAM is far in excess of what you'll see in a desktop, and with multiple users running on a server or multiple processes, you really need that extra horsepower under the hood to make sure things run smoothly and quickly. With that, you also have different technologies that you'll see that they use for hard drive. SSD or solid state drives you'll see in servers. You also see that in newer desktops as well. One of the big advantages of using that with servers or server farms especially, or data centers, is that they're energy efficient. Even if it's just a little bit more energy efficiency, if you're adding it over hundreds of drives or dozens of drives, you'll see that adds up quickly. The same with it being quiet. You know, there's no moving parts in a solid-state drive, so you don't have any of that noise that you would have in the humming hard drive or it's spooling up or spooling down. Better performance. The input and output speeds is way faster than a typical non-solid-state drive. And the access time is also a lot quicker, so especially in a server environment where you need to access different information quickly, there's a huge advantage. They are a little more expensive, but the advantages typically offset that. They're also durable since there's no moving parts to wear out or heads to crash or any of that stuff. So you'll see solid-state drives utilized sometimes in addition to normal hard drives in server applications. Also with the server hard drives, you'll see that most times they'll use a RAID or a redundant array of inexpensive or independent disks. There's several popular types of RAID. The more common ones you'll see is RAID 0, which is a striped set of drives, which means if you had two drives, the first bit of information would go on the first drive, and then the second bit would go on the second drive, and then it would go back to the first drive. So each drive would hold half of the file, so to speak. And then RAID 1, which is a mirrored drive, so if you had two different drives, they would both be basically copies of each other, so then if one failed, you'd have redundancy of the other one, which in server applications with businesses, that is important. RAID 5, which is striped with parity, so that would be, typically you see that with at least 3 drives, because it would be striped, and then there would be a parity drive that would enable some redundancy of the striped data if there was a loss of drive. And then the other two types are kind of a hybrid type, RAID 0+1 and RAID 1+0. RAID 0+1 is striped and then it's mirrored, so you will have different sets of drives that are striped, and then those sets are mirrored with a different set. And then RAID 1+0, there's different sets that are mirrored, and then they'll stripe those mirrors. So with business, data is critical, and you can't afford to lose any, so a lot of times you'll see that they spend the extra money to utilize redundancy at the more expense, but then it still saves them money in the long run because they don't have to worry about losing their data. Another thing that you may see with servers is NAS, or network attached storage. That has several benefits. It's central location and management, easy to share amongst several users or even several different servers, and fairly high capacity. Not all servers utilize that, but it is something that you do find in quite a few cases. And then with the RAM with the servers, they also utilize several different things. ECC, or error correcting code, you'll typically see with server RAM. That detects and corrects data corruption and provides fault tolerance. So there again, data is very critical in server environments. So with ECC, it enables it to correct most small errors and 1-bit errors of the RAM. And then the newest and really kind of coolest technology they have now, which they just developed kind of recently, is what they call persistent RAM. It's a hybrid RAM, and what it is it mixes regular DRAM and then flash memory along with a battery backup. So what that allows it to do is a normal RAM, if you were to lose power or there was a system lockup or system fault, you would lose all the information in normal RAM. Even regular server RAM, you would lose your information. With the new persistent memory, it allows you to, because of the battery backup and the flash, retain all the information that's in the RAM. Typically, it is a smaller capacity than normal server RAM, and it would be utilized in addition to that, but it is able to then hold still a fair amount of information that even if there was a system crash, that you would still be able to recover that information. So that's one of the newest things. I know HP just announced that they're going to start offering servers that support that. So that's kind of a new thing that's up and coming. Typically in a server you'll have several different operating systems that you could use. Windows servers, pretty popular. Linux and Unix we talked about in here, obviously. Bigger companies typically would have a custom OS based upon, say, Linux or Unix or Windows Server. As you get into the Googles and Facebooks of the world, they write their own stuff, basically. One of the big things with servers is it's mission critical, so a lot of the components are designed to be redundant or removed while the server is still running, and we touched on that a little bit in class here. Some of the things you'll see that are designed that way are the power supplies, the fans, and the hard drives even. So if one fails, you don't have to turn the server off or shut down the software. You can just pull that back component out and put in a new one. And continue on your day. Into the Googles and Facebooks of the world, normal off-the-shelf servers that you would find at a computer website or a company that makes servers doesn't necessarily work the best for them. When you get to the size companies where you have thousands of servers and data centers or several data centers, it becomes important to optimize the servers for your needs, because every server has a little bit different functions. So Facebook actually started what they call the Open Compute Project back in 2009. They actually took off-the-shelf, processors and hard drives and RAM and designed their own custom servers to best run the applications they needed it to run. And in doing all that research, they determined that they made their own servers that saved them a lot of money because they had tens of thousands of them they ended up making. But they also decided to share that information of making custom servers with everybody else. So they've started what they call the Open Compute Project, which is now also has partners with Intel and other hardware manufacturers. So if you are a company that is up to the enterprise level and you're looking for server hardware and normal servers aren't the best solution for you, then you can look into the Open Compute Project. So as you can see, servers are typically designed to be a lot more robust and durable than a standard desktop computer. They're designed to be run 24 hours a day, 7 days a week, under heavy workloads and adverse conditions. So everything is designed a lot more capable than a typical desktop computer or laptop. And that concludes my presentation on server hardware. Yes?
Just one. I know we talked about during the research as far as what's the general consensus, your consensus, I guess, on servers versus cloud space. What's your consensus on that? What's your feeling where we're going?
Well, I think we're leaning more and more toward the cloud. I was just reading an article today, though, that was very interesting to me. Apple has their Apple Music thing, and there was an actual music composer that had signed up for Apple Music. And what it did is it looked at all his music and uploaded it to the cloud, and then it deleted all of it off of his local storage, including the music he created himself. So then if he wanted to access the music he himself created, he had to download it from the cloud. So that is an important question for businesses, I think, is ownership of the data. If it's super mission critical, I think you need to keep it as local. Because then cloud hosting is great, but then it's like if you run into access problems or latency issues, especially if you're running large databases, the owner, and then the fact that technically if it's in the cloud, it may be more susceptible to hacking. So like government agencies may not want to have everything hosted in the cloud. So I see that even though everything is moving more toward the cloud, I still see that regular business-based, in their own four walls server hardware will continue for years to come. Yeah. Yes.
So is it, on the cloud, is it that's where you lease all in other words, you outsource all your data storage?
You can outsource storage, and they do software too. They do software as a service and all that other stuff.
So the cloud is basically another entity, whether a company or I don't know when they say.
Well, so like Amazon Web Services is one of the biggest players in the cloud, and they basically have data centers that they will lease you the server and the memory to do whatever you want, basically within parameters.
Well, good presentation. Let's give a hand. Excellent. Looks like you're getting pretty good on the cheese, but pepperoni not so high. Yeah, pop on a pepperoni. I'm gonna grab some apples here, and a carrot. Oh, yeah, good to go here. All right, Tim's up next. You can get the escape
Is this
key.
okay? Just leave that
The
as
escape
is.
key on that, Tim. Yeah, put this on. Just don't press that button. Right there. Don't press that button. No. I know. I'm picking on Tim. You probably, yeah.
Okay,
well,
so I just want to actually I could get rid of this. So, yeah, there we go.
All right. Good.
Okay.
All right. You gotta get some more stuff.
Okay, my topic today is going to be a survey of protocols used by the Internet Suite, and that's the main ones. The ones first developed were the Transmission Control Protocol and the Internet Protocol. Just a quick definition of the Internet is it's two components, the hardware and the software. And so the hardware is all the devices involved. Software are the protocols or the sets of rules or the recipes that the machines follow to complete their tasks. And in order for these to work, they need a common method and a common language to talk to each other. Internet could be considered the largest machine on Earth, and the TCP/IP protocols establish the rules for how all the information passes through it. Without these rules, you wouldn't have networks being able to talk to each other outside of a local connection to connection. This just is a basic summary of the architecture of how something moves from a client to a server and then back again. And then so we have the router. The routers find the quickest, most efficient way to get to the server, and then the server sends the message back. And it's just the definition is the set of communication protocols used on the Internet. They are end-to-end data specifying how data should be packed, addressed, transmitted, routed, and received. And the whole thing is maintained by the Internet Engineering Task Force. It's a consortium, worldwide consortium, I assume, that decides on how this is done. Just a quick timeline on the Internet. 1969, the R&D was initiated by the Defense Research Project. 1972, Robert Kahn and Vincent Cerf developed satellite and ground-based radio packet networks used, and their main purpose was to have a simple design. You know, so you have these geniuses, but they think real simply of what we want to do. And they had this saying that it would run over 2 tin cans in a string. Very simple. In 1977, the network they conducted a test successfully between the U.S., the U.K., and Norway. 1982, the U.S. Department of Defense declares TCP/IP as the standard for all military computing. In 1989, AT&T agreed to place the TCP/IP code developed for Unix, and I suppose they did a lot of the code building into the machines at that time. And then down to the consumer level, 1995, Microsoft released native TCP/IP packs in their Windows 95. So by that time, it was the commonly accepted way. I guess there were other 3 or 4. Each big company would have their own protocols. IBM, Digital Equipment Corporation, and these mainframe people, and so it probably took quite a bit of work in the consortiums to come together on which system is going to be the most robust and best one to have. Again, here's the architecture. The color coding kind of gives you an idea of the basic thing where you're adding headers, you're adding modules as it moves through the layers, and each module is independent of the other, doesn't care which type of computer you're using, what the data you're sending. It's packaged in this header, and it flows down from the data to the user datagram, internet protocol, and then the link or the frame data for moving it from satellites and through cables. Then it moves actually to the server. I have an arrow there moving, and then when it gets on that side of the process, it starts taking away the outer headers until the end user just sees the data. And of course, then the reverse occurs when the data is sent back to the client. These are just basic functions: host addressing identification, packet routing, sending packets. All these are, I guess, basically design principles that they used. Internet layer is agnostic. That means it's kind of a theological term, but it means like you have a belief in a higher power, but you don't care which belief system you're in. You know, Christian, Islam, Jewish, this type of thing. But you have that, so it's neutral that way, so it can accept any data structures. And again, the original system was the ARPANET, which was the defense agency's predecessor to the internet. And that's where they developed the IP version 4, the 32-bit IP address system that's capable of, that's like 1 times 10 to the 9th or a billion hosts. Now they have the IP6, which is, 3 or 4 times, to 3 or 4 powers higher, so. And this is just a packet-to-packet IPS routes to a domain name server. Match is found. The proper IP address is there. The file is sent. So the metaphor of a jigsaw puzzle in a package. It goes there, but then it's reassembled in its proper order for the picture. And these are, again, abstraction layers that all went into the original design. The transport layer, this is the one that assures that you are getting your message. The 3-way handshake, it provides a reliable connection. And duplicate data arrives in order. Data is minimal error. It's not duplicate data is discarded. So it's a really efficient way of moving data. This is the next computer was used by Tim Berners-Lee at CERN, is the European Nuclear Research Center. And it was the world's first web server. And Al Gore, this is the guy Al Gore channeled that when he said that he invented the internet, he was actually Tim Berners-Lee. So, and in summary, the whole the idea of concepts and discoveries build on each other. So I mean, over time, you get with technology, things build. The last person learns, and then they learn something more, and then it just builds on itself like money in a bank, basically, compounds on itself. So with that, you have discovery. Well, I uplifted some of these images from NASA, and this is this is where discovery and concept will may drive our economy even further in the next generation by having missions. Similar to what the mission to the moon was in the 60s, gave us solid-state electronics, computers, the digital system of computation. So with that, the deep space now, this is a module that they're designing for the mission to Mars. Here's one of the deep space rockets that's being developed. And these are pictures from Mars Curiosity on the Mars surface. It's taking some soil samples. There's Curiosity there. And there's a mountain range in the back. It's on top of a dune. This one's kind of nice because it demonstrates there was water. Those are salt. They've determined those are saltwater channels there, erosion channels, which shows that there was water on the surface of Mars at one point. And then there's another self-portrait of Curiosity. And these are micro images, and these are the references. Scientific knowledge, money in the bank. How does the internet work? And Internet Protocol Suite on Wikipedia, and Cisco Beginner's Guide. So, any questions? ARPA? Well, when it got out into the general public? I guess with the Unix systems were used, but they were more specialized. But like from my own memory, it seems like when Windows started having email and that was like this is when the general public started. It kind of really mid '80s, yeah.
Well, what's amazing about it is, all of you guys probably seen your articles around the internet, there's great information about that, is we're still in the infancy stage when it comes to internet technology. We're in the 30 years of training, right? We're still like in baby steps stages still when it comes to internet, when it comes to networking in general. As far as where we're going to be in 10 years from now compared to where we're at now, like you mentioned, the compound growth exponentially is just going to be like what we're learning now, 5 years from now, 10 years from now, will be like you may get all get speeds of 300 megabits download, right? You got 5 terabytes download now, it's slow, right? 5 terabytes per second download or something like 10 years from now, kids will be like, Dad, the internet's slow, I can download 10 minutes in 2 seconds, right? And so we're still in the infancy stage. And what's mind-boggling is that we're learning all this about networking and internet technology, but we're still in the infancy stages. So what that means to me is and it is constantly growing at a very fast rate. For students, it can be kind of overwhelming, but if you think about it, we're just going to be able to experience a slice of that motion or the time span of growth. And to just be a part of any of it, I think is pretty awesome. To be experiencing part of it is pretty awesome. So anyway, good job with your presentation.
Thank you.
All right. And let's please get some more pizza.
Oh yeah.
Take off the microphone, thank you. Appreciate it. And you did push a button, so great. All right, awesome. And so let's do a refill again on the plates, please. So I won't have to eat all the pizza there.
And before you launch that, I want to get.
Oh yeah. Oh, you want the command prompt? I've got it right down here, and then you want the terminal?
Yeah,
Okay, cool.
I'll fix it up.
All right, so it's good, and I'll let you do the slideshow full screen, whatever you want to do, and then.
So push the button on this.
No, do not push the button. Do not push the button. All right, refresh your surveys there while you're getting all ready there.
You guys read that? All right. Well, I'm Michael Rocky, and I'm going to talk about email protocols. Before we do that, though, I want to talk a little bit about the history of the internet, and thanks to Tim, kind of covered some of that for me already. So email, short for electronic mail, is a technology used for sending and receiving messages over computer networks. I think we all probably take that for granted nowadays, but it wasn't always around. I think it could be tough to agree on the earliest form of electronic messaging. when I was working on my report and this presentation, I was thinking that maybe even the telegraph can be considered a form of email. You're sending messages over copper wires using a code. Here in this presentation, I identified one of the earliest uses of electronic mail. Automatic digital network. It was an early communication system used by the that was around the early 60s, around 1962. But the first glimpse of email as we know it today probably occurred in 1971 with the ARPANET, and Tim was talking about this a little bit. That was a network developed by another one by the U.S. Department of Defense through their Advanced Research Projects Agency. And in 1971, a guy named Ray Tomlinson sent the first email over the ARPANET. So the ARPANET used devices called IMPs, or interface message processors, to connect the parts of the network together. I think you could equate this to like a network switch or a router in today's terminology. I want to say it does say message. It's not referring to an email message, but messages as in electronic information, some of which could be an email. So pretty cool looking stuff. The ARPANET, one of the machines used on the ARPANET was the Honeywell 316, and I got a picture of it on the screen there. Kind of cool. Kind of looks like it might be something out of Star Trek, maybe. Pretty cool. Anyway, Tim mentioned this. The TCP/IP suite kind of first appeared on the ARPANET in the early 80s. I put down 1983. It could be 82, something like that. TCP/IP is really the foundation of the internet, and when you think about email, it's totally crucial to email even today. Email protocols run on top of TCP/IP. Before we get into the modern protocols, I want to talk a little bit about some early protocols. One of those is UUCP, or Unix to Unix copy. This is one that's not actually an email protocol, but it's a protocol used to transfer information and execute remote commands between systems. And you could use email on top of that. A UUCP email address is what I've got kind of on the top middle here. Looks a little bit different than from what we're used to today, which is on the bottom. With the UUCP address, you've got the user on the far right, and then you've got the server. Like server 3 is the server the user is on, but we have these other servers here to tell whoever's sending me an email how to get there. So in order to get to server 3, I got to go through server 2 and server 1. And we look at an email address today, got the user on the left, the familiar @ symbol, and then the domain name or address of the server on the right. All right, so we're going to talk about more modern email protocols. But before we do that, I thought we'd review a little bit of networking. TCP, that's the Transport Control Protocol, handles connections between hosts on particular port numbers. So you'll make a connection with TCP, you keep the connection open, you exchange information, and then you close the connection. DNS, the domain name service, kind of like an internet phone book. You type in or look up a domain name like rockvalleycollege.edu, and you get back the IP address, internet protocol address of that domain. That's heavily used in email. One part of DNS, one of the things you can look up in DNS is what's called an MX record, which stands for Mail Exchanger. And if I wanted to send somebody an email that has an email address at rockvalleycollege.edu, I would need to look up their MX record to find out what the mail servers are for that domain. All right. Let's get into some actual protocols. SMTP stands for the Simple Mail Transport Protocol, and I like to call it the bread and butter of email protocols. It's something that's been around quite a while and still in use today. There are a few varieties of SMTP, but they basically perform the same function. They accept messages from clients to be sent and are also receive messages from other servers to be delivered. SMTP uses ports 25 and 587 with TCP. So a client might make a TCP connection to their mail server over port 587, send some information, which is a message, and then close that connection. So we just talked about SMTP, that's how to send and deliver mail, but how would a user retrieve some messages? We have different protocols for message retrieval. In the early days, you may have used a program called Mail or Elm or Pine. I've got a screenshot of Pine up on the screen here. There was a text-based mail client used back in 1992. Elm was another one, very popular in the 80s. I think that came out in 1986. But we're on to other things today. POP3, Post Office Protocol, is the third version of a mail retrieval protocol. It was pretty popular in the 90s. It's dropped off quite a bit recently with other more advanced protocols, such as IMAP, the Internet Message Access Protocol. Difference between IMAP and POP3, with POP3, you're pretty much calling up the server and saying, give me all the messages, and then delete them. And I get those and put them on my computer. Whereas with IMAP, the stuff is pretty much living on the server, and you can make a copy of it locally, which is really great if you have multiple devices. Like a lot of us today might have a phone, a laptop, and a desktop. And with POP, you download the messages onto your desktop, and then they're gone. They're only on your desktop. Whereas with IMAP, you can kind of access the same folder tree of messages from any device. Even more recent, I think, HTTP. This is Hypertext Transfer Protocol. This is another one of those protocols that's not actually for email, but this is the one that drives the web, and more recently, web services, which a lot of apps on your phone might use to exchange information. So if you think about like Gmail, you guys saw me logging into my Gmail just a minute ago. I'm using HTTP to get to that, to access my email. Interestingly though, even all of us accessing all this stuff over HTTP, on the back end, the servers are still using SMTP to exchange messages. So conversation about email would not be complete without talking about spam. And I'm not talking about the food products. The first spam email was sent in 1978 by somebody named Gary Thurk from the Digital Equipment Corporation. And Tim mentioned that company, a big mainframe computer company. And I have a copy of the first spam email to share with you. So basically, this guy was sending out an email to a bunch of people on the ARPANET to say, you need to buy this mainframe computer. I have a picture of one of those computers mentioned in the spam. Thought that'd be fun to share with you all. Over the years, it's been a bit of a cat and mouse game, I think, with system administrators and software vendors with spam. The spammers come up with a way to game the system, and then the software vendors and system administrators kind of quash that avenue that they found. One example of that is lying about who is sending a message. I can send a message and make it seem like it came from somebody even though it really didn't. And a way that vendors and system administrators have fought that particular problem is by something called SPF. That's the Sender Policy Framework. It's something where we put a record into DNS, kind of like that MX record I mentioned, but it's sort of the reverse of that. It's saying these systems are allowed to send email from this domain. I'm actually going to demonstrate that in a minute here, so you get to see more of that. Before we do that, I have a little diagram here, and I'm going to describe an example mail flow for you. Looks kind of crazy. We're going to start in the upper left. I don't know if you can see my mouse. You guys see that? So let's say we're going to send an email from Bob to Frank. So here's Bob's email address. Here's Frank's email address. Bob is the sender. So let's say Bob's typing away on his computer. He types up his email. He's going to send it to Frank. He hits send. As soon as he hits send, his email client makes a TCP connection to his SMTP server over port 587, sticks the message over through that connection, closes the connection. Then Bob is done. Bob thinks he's sent his message, but there's actually a bunch of other steps going on that Bob doesn't even realize are happening. So Bob's SMTP server takes a look at the recipient. Okay, it's Frank. at school.edu. So first thing that I need to do is find out what mail server do I need to send this message to for school.edu. So Bob's mail server, SMTP server, goes out to DNS, gets the MX record for school.edu, and finds out, oh, okay, I need to send it to mail.school.edu. It then makes a connection over port 25 to that server, and I'm calling that the recipient's SMTP server over here. And then Frank's mail server gets the message. It appears to be from Bob, but it's not really sure, so it looks in DNS for that SPF record I mentioned. Okay, is this message really legit from Bob? Okay, maybe it is. So I'll go ahead and deliver it into Frank's email box, and then Frank's mail client may download that message. Maybe that's his phone or his computer or whatever. So that's the very quick mail flow explanation. And now I'm going to take you behind the scenes, and we're going to do part of this diagram in real life. So I've got my own email address, mike@rocky.org. I'm going to send myself an email. So I'm the recipient. That's my school email address there. And we're going to skip the first box, and I'm just going to focus on kind of the middle here. I'm going to pretend like I've already transmitted the message, and my mail server is going to connect to Rock Valley College's mail server to deliver the message. So the first thing we need to do, I've got the message, I've got the domain, student.rockvalleycollege.edu. I need to find out what's the mail server for this domain. So we're going to look in DNS, and we're going to look for the MX record of student.rockvalleycollege.edu. Look at that. Lots of cool stuff. So we found out, yeah, this is the IP address of student.rockvalleycollege.edu, but that's really not what I'm interested in. I want to deliver an email, so I'm looking for the mail exchanger. Okay, so I see a list of them here. The first one's the top priority. We're going to use that one. One thing that's kind of interesting here is it doesn't say Rock Valley College, does it? It says Google Mail. That's because student email at Rock Valley College is hosted by Google. That's why we have Gmail. So I'm not actually going to be connecting to Rock Valley College to deliver this message to myself. I'm going to be connecting to Google. All right, so we have our mail server address. I'm going to make a connection now on port 25. Okay, and I made the connection, and it kind of says, yep, okay, you've connected to Google. Now what? So the first step in SMTP is to say hello. That's always polite, right? So we say hello with one L, and we say where we're coming from. Okay? So Google says, at your service. How nice. How polite. Okay, so the next thing we're going to do is we're going to say we're sending a mail from me. Okay, Google says okay, so far so good. And we're sending a message to, again, myself. Okay. You have to type it correctly. Luckily, they give you second chances here. Okay, Google says okay. We're doing good so far. And now I'm ready to transmit the data for my message. So what do I think I type? Data. Okay, go ahead, it says. How nice. So in an email message, you've got multiple parts, right? You've got the subject line. Everyone's familiar with that. But there's some other things in the message header that we're going to put in here. One of them is, you maybe take this for granted, but we're going to say who this is from. So I'm going to put my name, my email address. This is the part I was referring to where we could be lying, and I could say, it's Chuck Conkle or somebody else. Okay, we're going to say who it's from. We're going to say who I'm sending it to. Sending it to myself. Okay, we're going to say subject. All right, and now I'm ready to actually type my message. So, hello. All right, what a great message. All right, and then when I'm done with my data and done with my message, I put a dot on a single line, I hit enter. Google says, okay, and then we quit. So we just completed, on the diagram, we completed, oh my gosh. We just completed the middle step here, making the connection to the server over port 25. We completed getting the MX record. We skipped this SPF step, but I'll actually show you that. And now we'll check my mailbox, and with any luck, I'll have an email in there. Here we go. This is the email I just sent myself. And there it is. There's a message. You saw me type it. And let's take a look at the actual message. And you'll recognize this is some of the stuff you just saw me type out, right? From, to, subject. But look at all this other stuff here. This is all stuff that Google decided to put at the top of the message. Some interesting stuff here. You can see where it came from. Source IP address. You can see it doing that SPF check I mentioned. So it looked up my domain, saw, okay, you have an SPF record, and yep, you're good to go. Pass. And lots of other stuff here. One thing, look at this, it says missing. I neglected to put a message ID in my header, but apparently it still allowed me to send the message, so that was good. All right, so that concludes the demonstration and presentation. Email is a pretty broad topic, and I really have only scratched the surface here of the history. I mean, you could go nuts looking up stuff about the ARPANET and email protocols. And regarding the SMTP thing, there's a lot going on behind the scenes. When you hit send, a lot of stuff happens that you may not even think about. So anyway, I hope you enjoyed it. And any questions? Thanks.
Some of those ARPANET pictures you had, some of the early systems were awesome. And I've never seen a student do a command prompt email send, so.
Cool.
kudos to you.
All right.
That's awesome, by the way.
Thanks.
And I expect everybody now to do email this way.
Hey, it can be done.
It's actually not that difficult. It's actually pretty fun to do.
Yeah.
And so you might rewatch the video and just redo what he did on the video, and you can do the same thing he did, right?
Actually, I got something to share. I forgot to say this. If you go to Google and you type in SamLogic SMTP, you can find steps and more explanation of what's going on.
And everybody do that.
This is super cool.
Just to do it once at least.
Yeah.
That would be awesome. Yeah. Awesome presentation.
So,
Give me a hand.
all right, thanks. Can I push the button on this now? Or? Can I push the button?
Yeah, you